Well, my name is Alessandro Lasia. I work at Statistics Canada, and I'm chief of a group. We call ourselves the Data Exploration and Integration Lab. Maybe I should start with a confession, actually. I have to say, I came to this meeting a little bit like you would go on a blind date without knowing much. I was in Paris for an OECD meeting, so I didn't really have a lot of information and didn't know what to expect, so much so that 3 days ago, I think Karima sent me an email saying, "Oh, we didn't receive your presentation. Can you send it to us?" And I said, "Presentation?" I was thinking about a small room with 20 people exchanging idea. And then, just to ease pressure a little bit, this morning, she told me, "Oh, well, we are actually streaming live on Facebook, and your presentation will be on YouTube forever." I thought, okay, maybe I should review my presentation, but I didn't. So I have to say that so far for me it's been a fantastic blind date. I mean, a fantastic surprise for the venue, for the quality of the presentation, and the remarkable people that I had the opportunity to connect with. So really a fantastic surprise for me. I hope this presentation will provide you some insight and some food for thought, and we'll see. Hopefully it will be a fruitful exchange. So I kept the title of the presentation, International Challenges of Innovation-Rich Cities, but I add a very long subtitle. Oh, wow, sorry. Sorry about that. I have to get used to this. I added a very long subtitle, Insights from a Pilot Project to Explore New Frontiers in Data Collection, Mapping, and Municipal Open Data. And this is because I'm going to spend the first 2-3 minutes to summarize 2 years of research, a pilot project that we did at Statistics Canada. I led this pilot project. It was on data crowdsourcing. And then from there, I will go with some insights on international challenges for information-rich city, and maybe a suggestion for your research program, because I think that was one of the challenges. So I will give you a challenge as well. So let's start with a couple of slides on this pilot project. It was a pilot project on testing data crowdsourcing, the idea of crowdsourcing. So the purpose was to generate an in-depth understanding of how a national statistical office can mobilize contributor and existing technology to crowdsource data for the purpose of official statistics. So that was our perspective. It was a 2-year pilot project. It was completed in March this year, so we have a report under review, and then I would be very happy to share this report with you. What type of data did we crowdsource, and maybe why this is relevant for all this discussion we are having here? We crowdsourced georeference attribute of buildings, in particular footprints, addresses, type of use, name of businesses, and in the building, if there was any business. So fairly simple information. We selected 2 municipalities for the pilot project, Ottawa-Gatineau. This is the national capital region, for those of you who are not familiar with the geography of Canada. And what type of platform did we use for this? We use OpenStreetMap. I assume many of you are familiar with OpenStreetMap. For those of you who are not familiar, like myself when we started the project, it's a way in between Wikipedia and a mapping system, an open mapping system, in the sense that you create an account, you log in, and then you can edit a map the same way you would edit Wikipedia. And all the changes are tracked and recorded. So it's a map, but has some very nice, had some very nice attributes when we started the project. The first one is that it's actually there. We didn't have to build any infrastructure, create a new thing. The second one is that it has an active community of contributors, very active across globally and also in Canada. And then it's open data, and that was another very interesting feature for us for this project. So again, I will make a very, very long story short, and I'll give you the results to summarize this 2 years. So we started, and what you see here is not too clear, but in fact, I'm going to only show you one line, which is this blue line here, which is a little bit the story of the project in one graph, because this is the number of building polygons we had at the launch of the project and the number of building polygons we mapped at the end of the project. And here's the timeline. So we started the project in August, but we actually launched our online editor in October. And then basically in December, we had about 40,000 buildings, and all in a sudden, we had a jump to about 280,000 buildings. So the project was a success. In the span of 4 or 5 months, we managed to map Ottawa and Gatineau. And of course, there was some explanation about this success, and I'll get to that in a second. So again, a big jump. Just one point I would like to highlight, all this monitoring tool and the editing tool that we developed were developed with open source code, and they're available on a website. So results, again, we mapped Ottawa-Gatineau. It's a final report coming, and with all the insights we gained from this project. But let me highlight a couple of insights we got from the project. The first one is that crowd is indeed plural. I mean, there are many crowds. We started the project with this naive idea of people mapping. Indeed, the crowd is composed of individual as well as organization, informal and formal organization. And municipality were a big part of this picture. In fact, much of the success was due to the collaboration between a committed group of OSM OpenStreet mappers, expert mappers, and the municipality of Ottawa, and the fact that we imported municipal open data, which were made available to them. So the project was indeed an exploration, an opportunity to generate an understanding on open data in Canada, and it was a really eye-opener for the potential of municipal open data. So municipality, including cities, are indeed a data-rich environment. This is one of the first points that I would like to emphasize. In Canada, we have over 80 municipalities with open data portals, and when we start to dig and put together this information, we realized there were 3.4 million building footprints across Canada, which is start to be quite a large chunk. We estimated there are about 15 millions. So the potential for municipal open data, we realize, is still largely unutilized in Canada. Challenges for innovation-rich cities. What are some of the challenges that we realize? Again, I'll focus on a couple of them briefly. Well, the first one is that country jurisdiction may vary across, there are specific issues for country and jurisdiction. In Canada, for instance, municipalities are legislated at the provincial level, and this results in different, in a great diversity of responsibility at municipal level, so different data needs and incentive to put together data, open data at the municipal level. So there is maybe a consideration for international comparability of data-rich municipality. The second point is that we realize there is still a need to generate understanding on the value of municipal open data. So the first statement is obvious, is the starting point. Data support evidence-based decision-making. But when it comes to open data, I mean, we had the impression that stakeholders do not always have a full understanding of the value of their open data, and realize that more use cases are needed to demonstrate this value. Maybe you have experience on this and you can help us on this. Last point, well, another point, one of the data processing challenges are data integration. This is what we are facing now, because again, we start to look at the volume of municipal open data. So municipal building footprint, 3.5 million, civic address, 11 million open data in Canada. Land parcel and property value, 3+ million. Location of business, 0.5 million of municipal open data. So for us, one of the challenges is how to integrate this data in an environment that is continuously changing from the technological point of view. So an international challenge for you, and that's my last minute. So I took the first sentence from the speaker notes, and I will focus on idea for the contextualization and conceptualization of city. A possible idea. It's not very clear here. Can you guess what this is? Maybe it's not too clear. I move a little bit closer. Can you guess? I want to see somebody raising his hand and say, oh, I can recognize this. What is this? Excellent. This is your city. So this is a mapping of all the buildings, actually, of the Netherlands, done with open source data. And this is one example of information on the color-shaded information on the year of construction of the building. For all the building of the Netherlands, about 10 million building footprint in the Netherlands. Is this the only place where you have this type of information? So this is not Stats Canada statistics. Okay, I did it because of my insomnia. I had two fantastic small boys that keep me awake at night. So I downloaded data from OpenStreetMap for these countries. And then I said, okay, how can we understand if the database is complete? So I compared that with the population of the country and generate a ratio, population to building. So there are 11 countries for which you have a ratio population to building that is pretty much what you would expect to see when the mapping is complete, around 3, right? 3 people per building. France has 46 million open data on OpenStreetMap. Again, Germany, 27 million, et cetera, et cetera. In total, 109 million building footprint for these countries. Is this good for an Academy of Data Science? I think so. I think there is a great challenge here. In total, with all the other OECD countries, you have 176 million building footprint that you can use. It's open data, it's there. So my point is, there is already a wealth of open data related to city and urban morphology. Can we improve our open source tools? And I put open source because I think it's very important to analyze open georeference data on urban morphology, for instance, creating an R package on city and use that to create it. So that's my challenge for you. Maybe we'll meet each other in 1 year, 2 years with something that will use this wealth of data for some understanding of urban morphology. Thank you very much.